So, example 8, 2 identical curling stones. Oddly enough, I did a little bit of research. Curling stones, the rules of curling don't actually say that they have to weigh a certain amount. They're just sort of by convention, a certain mass. I don't think it's 19.5 kilograms, but there are slight variations, and you'll see sometimes curlers, they'll match the rocks, trying to get 2 rocks together that are identical or that are very close for each thrower so that they can sort of feel more comfortable kind of thing. So these collide as shown, and this is just a picture out of your book, so it's really not as shown, right? The first stone hits the stationary second stone with a velocity of 5 meters per second north. If the velocity of the first stone was 3.2 north, 30 west after collision, find the velocity of the second stone after the collision amid friction. And then when I say find the velocity, I also mean what? Including the direction. Okay. Now, as you know, quite often when curling stones hit each other and they're not sort of head-on, they'll sort of take off at different angles. And that's exactly what's happening here. Okay? But momentum will be conserved. I'm just going to make this a bit smaller here, give myself a little bit more space. I'm sure no one actually drew that picture. Okay, so I've got one, and I'm going to just do them in blue and red. Is that okay? And if you want to label them A and B, that's fine, because I'm sure you don't have blue and red with you. But I'll try to keep them separate here. Okay, so this is the stationary one. It has a velocity of 0. And the red one is moving at 5 meters per second. And it's moving straight north. But it doesn't hit the blue one head on. And so after, the velocity of the first one is 3.2 meters per second north, 30 west. So after the collision, the red one is headed off this way at 30 degrees. So that would imply then that the blue one would be headed off in that direction, right? And our job is to find the angle and the speed, keeping in mind that momentum is conserved. We'll find out. Now, I have to, fair warning here, these can get, there's various, when I sort of put this all together, there's various thoughts on all this. One of them is that the angle must always be 90 degrees. One of them is that if you, there is going to be some loss of kinetic energy. I basically just threw numbers in here, okay? This may or may not sort of happen in real life kind of thing. It's actually quite a bit more complicated than I'm making it, so you are seeing a much simplified version of this. Okay? Just a sort of a disclaimer ahead of time. Let's start by saying that the initial momentum must equal the final momentum, but it must be two-dimensional. Now, here's where the subscripts get ridiculous. Okay, in fact, I'm going to have a look here. I'm going to call these 1 and 2. I'm going to label this one rock 1 and this one rock 2. Okay, so I'm going to write PI1, and I'm going to put a vector above it, is equal to PI, sorry, got this back. Did you write that down already? Just to keep in uniform with my notes here. This is P1I, and this is going to be P1F, and this is going to be P2F, and those are all vectors. Okay, so the initial momentum of rock 1 is equal to the final momentum of rock 1 plus the final momentum of rock 2 in vector format. Okay, we are looking for the velocity of the second stone. Before I can get the velocity of the second stone, I need to find the momentum of the second stone. So now I'm going to rearrange this for P2F, this one here. Well, that's going to be equal to P1I minus P1F. I'm just going to pause there and let you look at that. It's a little confusing. This is vector subtraction. And how do we subtract vectors? We use components. We use components. You mispronounced that, Dan. It's pronounced yay. Oh, that was you? Oh.
I was saying game.
Oh, you were. Okay, good. Okay, so I'm going to write this out here. This is one way to just show it here. P2F, and I moved over a little bit because I've got quite a bit of space. So really, I'm talking about P1I is going to be, we got to figure out the momentum, right? So that's going to be 19.5 times 5, mass times velocity, north, minus P1F is going to be 19.5 times 3.2 north 30 west. And the reason I did that is I just wanted to sort of show you what vectors we're subtracting. Okay? And that multiplies out to 97.5 north minus 62.4 north 30 west. And now it literally becomes a straightforward Unit 1 vector subtraction question. So that's a good chance for us to review that. Maybe those of you that struggled with it at that time will now magically discover that you can do it. Won't that be wonderful? Okay, so convert to components. More subscripts. Okay, so 97.5 north. Now, fortunately, this let's designate north and south as y and east and west as x. Okay, does that make sense? Okay, so to break this into components, this is P1 IY, crazy subscripts. P1 IY is going to be 97.5, right? I got to take this vector right here and convert it into x and y components. It only has a y component. P1IX is 0. That was easy. The hard one is the next one, north 30 west. So that's going to be the second one here, P1F, right? So P1FY and P1FX. These components right here. No, P2 is P1I minus P1F, right? They're both rock 1. Okay, so I got to take this value here. So this is going to be 62.4. This is my x right here. Really, Garrett, there was no sound?
Yeah, and it's on.
Okay, don't feel shame. X and Y, right? Okay, and this here is 30 degrees, and I'm trying to go as slow as I can here. Am I going too fast? Yeah? Really? The x is adjacent, sorry, the y is adjacent, the x is opposite, right? So y is going to be cosine. So this is going to be P1, this value here, 62.4. It's the y, it's adjacent, so 62.4. Oh, Mr. Ben, oh yeah. How did I do that? 62.4 cosine 30. $62.4. That was the 19.5 times the 3.2. That's the momentum of the first rock after, right? So 62.4 cos 30 is, do you get 54? And this one here is going to be 62.4 sine 30, which is 31.2. Now that one is actually to the left, and so it's negative, right? I'll pause. When I'm all done, you guys, I'm going to go back and I'm going to go through it again, okay? Like, you know, at a quicker pace. But. Okay, now remember, what are we doing here? Subtracting. I'm subtracting this vector, subtract this vector. This vector, subtract this one, right? So it's going to be 97.5, subtract that, and 0 minus that. And that's going to be my P2F. So P2FY is going to be 97.5 minus 54. And I'll write it out right there again if you want. And you get 43.5. And here, P2Fx is going to be 0 subtract minus 31.2 or 31.2. Pause again. What's the next step in a vector subtraction question? Once you've done the vector subtraction, then what? Take the two components in, put them back together. Draw a picture and put them back together. Right? Convert these components to a single vector. So it's going to be 43.5 is the y component, and the x component is 31.2. And this is the, what color was my original rock? The blue one. This is the blue rock traveling that way, which is what we said, right? And what is its actual value here? P2F squared is going to be 31.2 squared plus 43.5 squared. And what does that equal? 53.5 kilogram meters per second. Is that what I was asked? No. What was I actually asked? The velocity. Is it easy to find the velocity? Yeah, here it actually becomes pretty easy, right? T equals mv. 53.5, the mass was 19.5. Solve for v, and you get 2.7 meters per second. And of course, you're also going to need an angle. And you get north 36 east. Aren't you glad that I put this off until after Christmas? No? Shall we go back and sort of look at it from a sort of step-by-step kind of thing and not worry about the numbers? Let's do that to try to nail down what the steps are here. Okay? Again, this is a two-dimensional conservation of momentum collision, right? Collision. Can I go back to the top? Okay. So, I drew my picture. I said Pi is equal to Pf. And then I figured out what did I have. Well, I had an initial momentum on the, I only had rock 1 moving to begin with, right? So P1I is equal to the momentums of rock 1 and rock 2 after. I guess I could, but P2I is equal to 0. So I just omitted it. Okay? And then because I'm looking for the velocity of the second stone, right, this is what I have to solve for. And so I took the P1F to the other side and flipped them, right? So I've got P1I minus P1F, which is what I wrote here. and that's equal to P2, right? And then I realized, okay, this is vector subtraction. So what are my values? What are the values of the vectors that I have to subtract? P2F is equal to, this is P1I right here, mass 19.5 times the velocity. P1F is the mass 19.5 times the velocity 3.2 in vector format, and I multiplied that out. And then I said, okay, I have to subtract 97.5 north minus 62.4 at north 30 west. Those are my vectors that I have to subtract. Then it becomes, and I use the air quotes, straightforward vector subtraction question, right? So I convert my 97.5 to components. It is only in the y component direction. The P1IX is 0, right? Convert this one to components. The y is 54. It's adjacent. I use cosine. The x is opposite, so I use sine. So then it's, why is it minus 31.2? Because it's to the left, right? This is up. And we know it's vector subtraction. That's what the big blue line is there, is subtract. So it's 97.5 minus 54 is 43.5. 0 minus 31.2 is 31.2. These are my x and y components of the rock 2 after the collision. And then I convert those y and x components into a single vector by Pythagoras. And then I divide by the mass to find the velocity. And then I find my angle. Easy as pie. Great question, Joey. How many marks? Let's see here. 1, 2, 3. Probably 4 for that. And maybe 5, 6. And I guess actually you'd probably get at least 1 for this stuff up here, right? So what was I at? 6? So probably in the 7 to 8 range.
So you just have to go up to building the triangle faster.
That's the spirit, Jake. Well, but then I only have to mark half of it correctly. Well, because if you only had to do 50%, then I only had to do 50%, right? So I'm only 50% accurate on my marking, which puts you at a 25%. Maybe I'm only half right in what I showed you here. Maybe half of this is wrong.
Would we ever add? And if we did, what situation would that be?
That's a good question. I don't know. Off the top of my head, I can't tell you what happened when you do this.
So like 90% of the time is subtract?
I think so, yeah.
But when you add, it's just the exact same.
Well, I mean, what's different? The simplest step, this one right here, right? Instead of subtract, you add.
Oh.
Right? I mean, let's face it, when we did that initial unit on vectors, I actually gave you 10 marks on the test. One was for addition, one was for subtraction, but they were identical except for one thing, the addition or the subtraction step.
I can't remember.
Yeah. Okay, I hate to tell you this, but the next one's a little harder. I'll give you a moment to write it down. The good news is that there is actually one easy part to this that's required. Pardon me? Don't know. 5 kilogram bomb at rest explodes into 3 pieces, each of which travels parallel to the ground. So they've simplified it. You've got this thing that becomes 3 pieces that go like that, right? And I just sort of sketched that. The first piece with a mass of 1.2 travels at 5.5 meters per second at an angle of 20 degrees south of east. 20 degrees south of east. So that's going to be like that, right? The second piece has a mass of 2.5 and travels at 4.1 at an angle of 25 north of east. Do it in a different color. North of east. North of east. The third piece is going to go, well, we're not really sure. Something like that, right? What's the one thing you need to know that they don't tell you in the question? Mass of the third piece. Is it easy to find? Yeah, it is. It's actually pretty easy, right? Mass of the third piece is going to be 5 minus 1.2 minus 2.5. Please make sure you at least get that part right. Okay. I said it once, I'm going to say it again. PI is equal to PF. What is the initial momentum? Big fat 0. Which I say actually makes things easier because that whole left side just doesn't exist really, right? Okay, and that's equal to, so I don't even need to worry about the final or the prime or anything about that because, right? So that's a good thing. So I'm just going to write P1 plus P2 plus P3. And again, if you want to be technical, these are all vectors. Now,
So, if we just, if like, if we work it up, PI would be P1, I, P plus P2.
Yep.
Plus P3, but they're all starting for us now.
so they're all 0, yes. Yep. Now, since PI is equal to 0, that means then that the sum of the x components is 0, and the sum of the y components also 0. And that's what we're going to use. Okay, so zero is equal to P1x plus P2x plus P3x. All I did was just rewrite that statement there, but said it's for the x components. We are trying to find the speed of piece 3. Piece 3, x component. These two guys go to the other side and become negative. So minus P1x minus P2x. Is the same thing true for the y's? Yep. Sum of x and sum of y, Peyton. Is the same thing true for the y's? Absolutely. I'm going to write it over here. And again, this is for sort of completeness of solution, the presentation here. 0 is equal to P1y plus P2y plus P3y. And P3y is simply going to be minus P1y minus P2y. Before I go too much further, I want to congratulate you. Think about halfway through grade 11. If I'd given you something like this, what would you have done? Or walked out on me and quit or whatever, right? Have you come a long way since then? Yes, you have. Yes, you have. Back then, you were still struggling with F equals MA, for crying out loud.
It's still very difficult.
I'm not saying that it's not. But you guys have come a long ways. Okay. So what do I have to do here now? I got to find the x component of piece 1, and I got to find the x component of 2, right? Basically what I should do is I should take those pieces and find out the x and y components. So let's draw them here. So P1 and P2. P1 was like this, right? Oh, by the way, 1. Okay, P1 is We don't even know yet, do we, here? Piece 1 is 1.2 times 5.5 at 20 south of east. One point two times 5.5 . This is P1x, P1y. So P1x is going to be, and the angle was 20 degrees. So this is going to be 1.2 times 5.5 times the cosine of 50. Why cosine?
Is it 5.5 or just 5?
Oh, I see 5.5. These notes aren't very good. 1.2 times 5.5 times. Oh, I'm in radians. Don't be in radians. Go ahead. I get 4.24. And it's to the right, so it's going to be positive, right? We probably could have, yeah. I mean, the order of things is... Yeah. I was sort of giving you the theory kind of thing, and now I'm doing the... Yeah. Cos 20. Oh, that's not right. $6.2, right? Okay. P1y, I'll do the y's over here. Y is down, negative. So this is going to be 1.2 times 5.5. I should probably just have that number already, right? Like, there's no sense in me redoing it, but I didn't. 0.2 times 5.5 times 20. If you could, it'd be really nice if you guys all got this right on the test, because it's much easier to mark. Could you do that for me? Just to make my life a little easier, I'd sure appreciate that. 2.26. Down, so it's negative. Let's do the same for P2. P2 was 2.5 and 4.1 at an angle of 25. 2.5 and 4.1. It was up like this. X is adjacent, cosine 25. $9.29 to the right, so positive. Y here is going to be 4.33 up, so it's positive. Okay, so I broke it into components, right? pause for a second. Okay, so now I have to take these values and throw them into what I've done in red here, right? Now, I heard you say, Brandon, we subtract them, right? Well, remember, subtraction is really just a form of addition, really, isn't it, right? Like, I'm taking these two. You could say, I guess, if you wanted, you could say, I'm going to take minus P1x and I'm going to subtract P2x. Well, I'm going to come back at you and say, I'm going to add the negatives together. Same thing, really, right? Because I've got negatives in front of it. So P3x is the negative of this, subtract the negative of that, right? So I'm just going to rewrite that little bit right here. In fact, I'm going to actually just, well, no, I'm not. I'm going to write P3x is minus P1x minus P2x, and then I'm going to do it. Minus 6.2 subtract minus 9.29. .5. And over here, same thing. P3y is minus P1y minus P2y. Now, be careful. This is already a negative. Is that the same negative as this one? No. What's the most likely mistake you're going to make in this kind of question? Something like that. Be very careful. And again, showing your work allows me to see where your mistakes are, which allows me to sort of find out what you do know and give you some credit. So, as always, please show your work. I've almost got all the grade 11s trained to show their work. Okay, so this is going to be negative times negative. This is going to be positive 2.26 minus 4.33, and you get negative 2.07. Which way should this piece be going? Go back to the start. We estimated kind of like that, right? Certainly to the left. Do we really know whether it's going to be up or down? Not really, right? We'd have to take a closer look at the mass here, so it could easily be like that, right? We're not really sure. If we look closer, we could figure it out. But do we have something like that? I heard someone say it. The x is negative, that's good, and the y is negative. So what does it end up being? It's kind of like a little bit like that, right? And if you look at the size of them and the speeds, you would say, oh yeah, okay, that makes sense. Okay, what's the next step? Like, what do I do now to solve? Make the triangle. I got to take components and put them together. We've done this over and over again. Draw the triangle. It's negative and negative, so 15.5 and 2.07, and this is P3. So P3 squared is equal to 15.5 squared plus 2.07 squared. Do the math. I get 15.6. Does that seem about right? Yeah, I think so. 15.6, and that is kilogram meters per second. Oh, yay, it's what I got on here too. Good. Good for me. Next step, we are asked to find the velocity. So again, we're going to go back to P equals mv, 15.6. The mass of the third piece, make sure you got everything labeled and everything here, because we're going to have to go looking for it. 1.3. .12 meters per second, and of course you're going to need an angle. Well, that wasn't too bad. Yeah, I did too. I rounded it to 8. I've decided that no longer will we do decimals on angles. They're just too small. Okay. Is that a challenging question? Absolutely. Is it going to take you some time to get to the point where you can do these? Yes. It's like me throwing out a new piece in band. You can't play it right away. It takes practice. Okay, and you're going to have to look at it and sort of go through it. But forget the numbers, and again, let's go back and look at the steps, right? Because the steps are going to be the same. It's the numbers that made change, right? So what did I do? I found the mass of the third piece, right? I realized that the initial momentum was 0, and so the sum of the x components is 0, and the sum of the y components must be 0. That's both before and after, by the way. And so I said 0 is equal to the sum of the x, and 0 is equal to the sum of the y, which tells me then that P3x is really the sum of the other two x components, but in the opposite direction. That's what this is, right? These two added together have to equal this one so that the total is 0. And the same thing is true for the y. Then what did I do? I drew my P1, I found my x and my y. I drew my P2, I found my x and my y. And then I took those numbers and I inserted them into these equations that I came up with here in red. P3x is equal to minus P1x minus P2x and so on. And I was very careful with this negative sign over here. And I basically did the subtraction or the addition, or however which way you want to look at it. And once I got my components for my piece 3, I combined them together in the traditional fashion with the triangle and Pythagoras. And once I got my piece 3 momentum, I converted it to velocity by dividing by the mass. And then I found my angle. And yeah, it's a lot of work. Should you start in the middle of your workspace when you do something like this? No. Upper left-hand corner, write small, write neat, show your work, label stuff. It's going to make it a whole lot easier, right? I need to show this to grade 11s. Maybe I shouldn't, and I know I'm taking grade 12 next year. I won't do that. They've come a long way too. As have you guys. Any questions? Yeah. Stoughton's not doing this every time he makes a shot. There's some you can try. They're in the book, page 301, 1 to 4. It wouldn't be a terrible idea to read about police analysis of car accidents. They train RCMP members to do this sort of stuff. They don't quite do it in that fashion, but the general theory is the same. They can figure out who's at fault. Right? There's some there on page 312 as well.